Okay, guys. On Friday, we did a lab where we measured different substances. And what we had to do was we basically had to do a couple of conversions. After measuring those substances, we converted them to moles, and then we converted that into particles. Okay? And take a look at this. This is what the work looked like. So in our little containers, we measured mass of different chemicals. We then took the mass and we converted it to moles in one step. Okay, we had explained this previous. Then we took the answer from this problem and we then converted that answer into particles. So today we're not only going to focus on that, but we're also going to give you a better, shorter way of solving that problem versus breaking it into two steps. But first things first. So look back at the problem on page 318, which is 13A. 13A. We have, and you should have a piece of paper out and your calculator and all the tools of chemistry, including your periodic table. We have 55.2 grams of lithium. And in the instructions, it tells us to calculate how many atoms there are in the following sample. So this is identical to the type of problem you had to do in lab on Friday. Okay, so the first thing we did when converting to moles was we put a little time sign, our division line, and then we said, okay, what we want goes down below the line. I'm sorry, what we have goes down below the line, and what we want goes above it. So we have grams of Li. What we want are moles of Li. We're going to solve this exactly like we solved Friday's problems. Now, where did we say was a great place to find grams of lithium? The periodic table, of course. So we go to the periodic table, we look at S block, and we find lithium's value. It is 6.94. That is the amount present in 1 mole of lithium. It's called its molar mass. We then cross-canceled our like units, and we simply divided the two. 55.2 divided by 6.94. And what I get for an answer here is 7.95, and then a whole bunch of other digits that come with it. Okay? Now, as of this point, we are currently in moles of lithium. But that's not what 13A's instructions tells us to find. It says to find how many atoms are in the following. So just like on Friday, what we're going to do is we'll use this 7.95 as a new starting point of our next problem. So if I have 7.95 moles of lithium, what I can do is put a time sign, a division line. What I have goes down below the line, which is moles of lithium, and what I want goes above the line, which is atoms of lithium. Now, does anyone remember from Friday how you solved this? What did you put above the line and below the line? Anybody remember? Well, what is the numerical relationship between moles of something and number of particles? Avogadro's number is the amount of things present in a mole of anything. So if I have 1 mole lithium, I have Avogadro's number of particles. And in this case, it happens to be atoms. So our next step, and you did this on Friday, cross-cancel your like units. Go ahead and multiply your two top values together, and you'll have the right answer. Remember to make use of your parentheses as you do this, so your calculator doesn't get confused. And I'm winding up with 4.788 and a whole bunch of other digits with it, times 10 to the 24th. Remember, if it says E24, that means times 10 to the 24th power. Now, the last thing we want to do is we want to polish up our answer with the correct number of sig figs. How many sig figs started off this problem? 3. Therefore, we must report 3 on our answer, so it would be 4.7. Guys, help me out. 9 times 10 to the 24th, and that's atoms of lithium. Okay, and you give it a circle for a good final answer. Okay, so why did we go ahead and copy down that picture from page 319? Well, we copied it down because we call that the mole map. It's a map that is going to show you exactly what to write down in a problem like this, so we don't have to separate it into 2 problems. Instead, we can keep it as 1 problem and then just go ahead and solve it in one fell swoop. Okay?